setup. So from the next lecture onwards, we will be discussing directly what are the different concepts related to information retrieval and what are the different aspects of it. So we will be taking those uh, as basically our classes will be going further, right? So today, let me share your lecture note. Actually, this notes we used to share with you. So today's uh, p- theme is to understand what is the information and basically how information is gathered and how basically different characteristics of information detail uh, will help you to achieve this model, right? So, like in the previous class, we have taken the important concept called data, and so this pictorial representation of whole scenario is uh, basically having this 360-degree view on these concepts. So I hope it is visible to you, and this diagram is important to be taken as, right? So here you can see, like in the previous lecture, we have taken, okay, what is data, and basically how we are collecting the data and why we are collecting the data, and what are the basic features or basic characteristics of a data object, right? So here you can see, whenever we are going to design a system, whenever we are planning to design a system, whether it is information processing system or data processing system or any kind of system, like you can see here, we have kept all these possible level of detailing into these 4 dimensions, right? So first dimension is data, you can see here. Next one is information, then we have knowledge, then we have at last wisdom. So wisdom is something which is not clear, which is not yet established, that which system is working for processing the wisdom, or which system is generating the wisdom as output, right? So that's why I have kept as a question mark here in the fourth quadrant, probably, right? So because we have kept these 4 details or level of details about any real world requirement or any real world entity. So we cannot say that these 4 quadrants will be having details of 4 different entities. No, we can have the so these 4 are the levels of details, right? Data is one. The data is the first level of detail about any real world requirement or any real world entity, right? So if you further these details, these data objects, and add something into it, it will become information, which is the second level of detail about the same entity. Similarly, if you further go by using these information object and add something into it, or maybe process, or maybe feed these information objects to a system, it will generate some additional kind of or a more abstracted version of detail about the same real world object or same real world requirement, and it is referred as a knowledge. Similarly, if you go further, so that will be the largest or highest level of detailing, which is referred as a wisdom. So these 4 levels are detail about objects are basically derived based on the requirement, right? There is no compulsion, like in the case of database normalization. You might recall this fact, that in case of database normalization, it is not always necessary to go for the highest form or highest level of normal form. It is up to your approach. You can design or you can normalize your database up to maybe the second normal form or maybe third normal form. So it is always up to your requirement, right? It is not necessary to process a data and make it go up to the level of knowledge. It is not necessary sometimes, right? So it is always up to the application need. It is always up to the business requirement, actually. Okay, so basically the first quadrant we have opened up about these details in the previous lecture. So here you can see in the first quadrant we have almost taken it as a discussion. So in the first quadrant you can see there is a cloud called real world requirement. So this is a space from where we are taking out the data, right? So it could be identity, it could be a business requirement also. So because database design is somehow parallel, it is a parallel activity to the software design. So whenever you are designing a software system, so there will be 2 parallel tracks. One track will be focusing on the interface design and the system architecture design. The second track will be focusing on the design of database. So if you start working on a software design or maybe software system design, you will be collecting all the requirements from the real world naturally. So it may be coming from a business requirement or maybe directly from a client requirements. So after collecting all those requirements, you need to separate the data requirements. So from the whole SRS, from the whole entire SRS documents, you need to separate those requirements, data requirements, so that we can perform this data design or database design as a separate track, right? So these are the requirements which are separated. So from the real world requirement or maybe from the SRS, you need to take out all those requirements, right? And then based on these requirements, you need to design the conceptual diagram or conceptual model of the data, which we have discussed in the previous class, and try to design these ER diagrams or these conceptual modeling uh, diagrams for the database. After that, after this design of conceptual, you will be going naturally for the logical data design, right? And sometimes it is obviously possible that you can identify the possible data objects, all right? Like in particular column, what will be the possible value? Like if your database is capturing the gender of the human being or the person or the employees, you can identify that for the gender column these are the two possible values. So these kind of conditions you can define during this data processing term, right? So data processing is the first processing which is involved in the life of data or in the life of any software system. So that in the data processing phase or in the data processing state, we will define the first print, I mean the first impression of the database, right? So that's why we are saying it is the conceptual, it involves the conceptual as well as logical design. Uh, and some definitions about the data, possible data which will be available or which will be submitted in the system. After data processing, naturally, we will be going for data modeling. So modeling means you have adapted a model, and based on that model, you will be defining the condition on the data, and basically you will have a structure. So that's why the second stage is called data modeling, where we adopt a model for our data, right? We adapt a model to be so basically that's what the definition we have taken in the data class, that data model basically gives you the representation, gives you the scope for how data will be stored and how data will be represented or shown. So whenever we say, okay, data model controls these two things, so it means data model will be applying some condition, applying some constraint on the database. So we have correctly taken that if you are going for relational data model, relational database, naturally there will be these constraints which will be imposed on the database. And because of these constraints, our database will be accepting only few types of values, right? So data modeling basically emphasize a particular phase, a particular lifetime where database will be added with some conditions, right? So while we have data in our hand, we have to perform only two aspects: data processing and data modeling. So here you can clearly correlate this term to a term called data mining and data warehousing. So I have kept these two terms, data processing and data modeling, uh, because these are the basic, or these are the fundamental processing or more activities which are performed. But if you refer this course called data mining or subject as a data mining, you can correlate each and every activities which are involved in data mining with these two terms, modeling and processing, right? Data processing. So we are in the very first quadrant where data is real world are the requirements and output is a data, right? And data naturally, so it is organized in the structured representation or structured storage device or structured storage manner. So the purpose of these data processing and modeling, and the purpose of all activity performed in the very first quadrant, is to add the syntax. So basically here we are applying, or we are providing some kind of syntax or maybe structure for the data which is captured, right? So that is the only motive of this first quadrant processing. Now, in some cases, so yeah, you can run your application, you can execute your software system by using these data, which is data objects which are captured and kept in the structure representation in the bottom, right? So that's one way, that's okay. So because most of the systems, maybe before 1990. So most of the systems are working or running on the data itself. It is not, they're not consuming information, right? So after that, after some times, they have realized, okay, because keeping this data in a structured way and retrieving the data for user query is one of the convenient way of processing. That's what we have considered. But adding something onto this data will achieve additional purposes, right? It will give you a lot of meaningful things, right? So that's why we have gone to the second quadrant now. So if you want to go uh, from first quadrant to second quadrant is basically referred as the quadrant for the information. So now information is the basic thing. If you take the basic definition, information is basically nothing but it is a processed data. So processed data means you are applying a basic form of processing on the top of the data. So you are consuming the data, and after consuming the data or taking the data as input, you will be applying some form of processing. It could be a simple abstraction, it could be a simple summarization of the data which we have taken as an input, right? So information, to achieve information, you can have any kind of processing. That is up to the application, that is up to the need, right? Because information we are generating for some purpose. It is not just like okay, you have data and now you can apply some processing and generate information. It is not like that. Information is always generated for some specific purpose, right? So the basic example, yeah, we will be taking an example for this. uh, so here you can see in the second quadrant, it is referring as a, so if we have data as input, if you want to generate information as output, you will be applying some kind of meaning, some kind of uh, no additional data, I can say, in a very plain way. So basically, one of the example we used to refer that in the social media platforms, uh, if you see that okay, maybe in my profile itself, I'm exploring the different posts or different uh, different information posted by the different users. I used to perform like and share and other operations. So these behaviors or maybe these actions by the different users on a particular post are considered as a semantics nowadays. So because whatever I am posting from my profile, whatever any user is posting from his profile is the data actually, right? So if you are typing a text or typing a post and submitting or sharing into the any social media platform, it is a plain data object, right? And if any other user is applying some activity, some behavior or something onto it, it will become it will become some kind of semantics into it, right? So if particular post is retweeted around 100 times or maybe 1,000 times or million times, it is additional data, it is the additional meaning onto that data, right? So it is not a data. You cannot say that that is, so number of tweets is not a data, it is additional data on a data. So that's why you can refer it as a metadata. So the metadata, the basic definition of metadata is what it describes the data. It is a data about data. So the basic definition of metadata we used to take as a uh, if you refer that, okay, some variable has been initialized like integer a as 10, something like that. So this integer a integer variable a as a 10 size. So this can be referred as a metadata because it is describing the structure of the data, the structure of a variable. Similarly, in the larger context, if you take this social media platform situation, so number of tweets or number of likes or number of shares are nothing but it is considered as a metadata, right? It is describing or it is emphasizing some aspect of the data. And that's why we are getting, so because of these kind of data which we are collecting now, our data object, our data has become as a big data, right? So big data is nothing but it is a conventional data only, but it has now no coming towards the companies, coming towards single individual user as in a different scales, right? We have not evolved with new data type because uh, in the previous lecture we have taken this term like in any particular time we could have three possible data type. First is structured, and then we have semi-structured, then we have unstructured, right? So within each category, within structure, within semi-structure, and within unstructured, we have same data types. So if you count among these three different categories, there is possibly 30 to 35 types of data, right? Like in case of unstructured, we could have video, audio files, text files, document files, all other different files. In the same structured class or category, you can have HTML pages or web RSS feeds and all those things. And in the very first bracket, which is called structured, we could have some kind of structured files or some kind of access data servers or something like that. So if you collect all these different data types, so though it could be up 30, 32 types of different types of data objects. So we have not evolved any different type, any additional type of data which we are referring as a big data. No, big data is the same data, same conventional types of data, but we have added, or maybe systems which are generating these data might have added these semantics, these additional data, these additional metadata onto it. Because of that, it becomes a big data, right? So you might have discussed these things in the previous semester itself, that big data is. So that's why we do not have any specific definition to the big data, because it is a data with new scales, data with new properties, right? So inherently, in the case of big data also, the data objects which we will be dealing is the same conventional data, but the scales are now different, right? Like we used to take this definition whenever some students say, sir, what is big data? So I used to say, maybe 10 years back, we have these emailing services like Gmail, Hotmail, Yahoo Mail, and those days it was not observed that we are facing some issues, right? We are not facing some issue which can be called as a big data, right? But after some maybe some years, we had realized that these Gmail or mailing services are not able to handle a file more than 35 MB. So it was suddenly observed, right? Just because we are having these kind of document files, which could be of size more than 30 MB, something like that. So now Gmail service is not able to handle a particular PDF file which is of more than 30 MB or something like that. So for Gmail service, this 35 MB PDF is a big data, because Gmail is not able to handle that. Gmail, so properties or features of Gmail or any emailing services are not able to handle this simple 35 MB PDF file, or maybe any other example as you can take. So big data you cannot generalize. So big data term is always with respect to certain application and with respect to certain feature of applications, right? So that's why after failure of Gmail for these size of files, we have evolved with new application, new platform, which is called Google Drive, something like that. So size is one issue which we have faced in various applications. So that's why the very first property of big data is volume, right? So volume of data, size of data is the very first issue which many applications has observed. So along with Gmail, there are various applications, there are various softwares which realize that, okay, now we are not able to handle a simple file, same PDF file, maybe just because of its size. Similarly, there are various applications which realizes that the data rate, the rate of data which is coming to their application, they are not able to handle. So now second dimension is called velocity. Velocity of data is a problem, because those applications are now not able to handle the incoming rate of the same data. So data is conventional, but the rate of generation of the data has been evolved because of the evolutions in the hardware, right? So because there is a theorem which refers that the development on the hardware side. So we have designed the uh, advanced hardwares. The rate of advancement in the hardware is, I mean, it is exceptionally, or maybe it is in the rate, it is in the range of exponential growth. So in the side of hardware development, it is exponential, but in the software side, we have evolved software in the very linear rate. So that's why suddenly we have realized that we are getting these data in increasingly or exponential rate, but our software is not able to handle it. So the second dimension is what it is called velocity. So whenever we are dealing with conventional data, the second dimension, which is velocity, could be a problem also. Third dimension is it is called veracity. So veracity means your system is now, or maybe your system is now forced to handle uh, different types of data. So it might be a case that your simple software needs to take care about the semi-structured, structured, and unstructured, all these three form of data. So here veracity will be problem. So similarly, along with these three dimensions, we have realized that there are around other V's also. So along with volume, velocity, and veracity, we are getting other V's also. You can claim that, sir, there are 8 V's, something like that. So these are the simple observations. So these property named as a V, velocity, volume, and veracity. Along with these, there are various V's, and these V's are basically based on some observations. So there might be some 3 or 4 applications in the US or maybe in any country which are facing some V. So they have named as a V, and this is becomes a problem. So they might have some mechanism to deal with these situations, right? So big data is basically nothing but it is a conventional data with some additional scale of particular property, right? So here we have taken the basic inference that whenever we are generating information, whenever it is asked to generate information on the additional data, on the traditional data, we will be adding some additional information, some additional detail, some additional in summarized value onto the data, right? So here we have correctly noted that it is simply adding semantics. So semantics means it could be annotation, it could be a simple metadata, it could be some processing which hides some part of information. Second week, it could be a simple processing referred as abstraction. So abstraction is naturally it will be hiding or summarizing something into it, right? So basically, yeah. So let me stop here. Yeah, so I got a call from office. Okay, so basically, the purpose of this information processing. So this process. So adding something on the data is called information processing. So whenever we are doing this activity like processing data and to add something onto it, it is called information processing. So here you can see. So whenever we are adding a particular information, particular detail on the data object, it is referred as a semantic. It is referred as semantic, right? So this additional detail is added and it will establish some kind of relationship between different objects. So here you can spot correctly that we have got these information object or maybe these data objects, and there is some kind of relationship between these different objects, right? Rightly mentioned here. So similarly, so whenever we have set of information object, so whenever in the database or maybe in the corpus or maybe in the storage devices, because so whenever we collect data objects, we used to say as a database or maybe data set. Whenever we have set of information objects, information object collection is referred as a corpus, right? So corpus means it is a bag of information objects, right? And it will have some relationship between each part of the additional information, right? So after this, so basically information is basically you can say it is a data with some information, data with some relationship, data with some summarized details, right? So you need to have this clarity about the property of data information object, because information object is something which we will be dealing in this whole semester, right? For any kind of information retrieval, you need to separate these additional detailings on the data. So the very first thing which information retrieval system is doing will be separating these data objects with information, this additional information, and this additional information on the data object will be used to perform different information retrieval related tasks, right? So the first question here I can pose to you that, can you tell me or can we guess here that how a basic information retrieval system is generating or arranging the, so let's have a basic information retrieval system, and let's have there is 100 documents which are available in the information corpus. So if my query is imposed, if user query is imposed on this system, and system generates some results, some documents, and based on this generation, so because to fetch or retrieve these basic matching documents, you can perform matching algorithm. But if out of these 100, 20 are selected, how you are arranging, what is the basis of arrangement of these 20 documents, how you are ranking these 20 documents. So here at this point you can answer to the question. So how system is arranging these 20 records which are fetched for a particular query, right? Can you tell me?
Sir, on the basis of relevance.
Yeah, relevance is very subjective criteria. Okay, because based on exact matching, we have fetched the 20. That's one part. Second part is you are required to arrange these 20 records in some form of ordering. So can you tell me any answer we can have?
So based on time,
Time. Okay, it is more abstract. Time means what?
sir, sir, time of
Okay. Let's time of okay. Yeah, so second, I think scenario is clear to you that we have a corpus. In corpus there are 100 documents, maybe some 100 PDFs. So if we want to identify that which PDF or which documents are relevant to you, so you will be simply applying a keyword, and based on simple keyword, based on your keyword, system have generated or selected 20 documents, and out of these 20, naturally these 20 are matching to you, matching to your keyword, but system has arranged these 20 records in some manner. So because retrieving the matching document is not an issue, you can have algorithm to exact match, string match, anything. But second issue is arrangement of these 20. You cannot place all these 20 in one position. You need to arrange these 20 in some order. So what could be the information, what could be the data you can use to arrange these 20? This
On
is a
the
very
basis of past,
fundamental.
on the
How
basis
many
of past
times the
experience.
string has repeated in the file?
Okay, that could be one thing. So you are talking about the very conventional criteria, which is called term frequency. Means term
Yes.
frequency could be one reason. Yes. Okay. Arbaz, what you're saying? So you are responding, I
Sir,
think.
on the basis of past experience means our previous searches.
Previous searches. So it is more wild actually. Your guess is relevant, but is more wild. Okay. We are going to Kuldeep. You want to say something?
no, sir.
Kuldeep.
No, sir.
Yeah. So no, sir. Okay. So because it is important to participate in the discussion. So whenever in the lecture we are raising a question, it is important to respond to that question, right?
Excuse me,
Initially,
sir.
you might have not any. Yes, please, Amit.
Sir, it will depend on how many times this particular paper is referred by the user.
Yeah. So you can have anything on it, right? So that's why I'm saying it is not necessary uh, that whatever guesses you have made, number of papers referred by user, number of terms appearing in the document. Yes, Kamaljit, you want to say something?
So it will be the number of times of the occurrence of a particular keyword or the probability.
Right. So we can have all these arrangements. We can have, so that's the emphasis here I wanted to make, that whenever we are having a information retrieval system, right? So it is not necessary that all these information along with the data, along with the PDF file, it is not necessary that in this corpus, it is not necessary that along with this PDF we have maintained all these information. It is not necessary. Like if you take Google search system, it is not maintaining all these information. It is simply maintaining the information which are related to the, so suppose in Google search there is a PDF available, there is a PDF stored in the Google corpus. They are maintaining primarily the terms which are appearing within the document, and might be its frequency, and might be the next possible term. So only 3 4 information or 3 4 additional details they're maintaining with our document, right? So it is the responsibility of information processing algorithm, right? So when we have converted this data into information and kept into the corpus, it is the responsibility of information processing system that time what are the details have kept with PDF or maybe any document, right? So because we are beginning, just beginning this syllabus, we are just beginning these concepts, so it looks like more open, right? But when you are, as an organization or as an individual, you are maintaining uh, these semantics. So semantics will have limited. You cannot store all the possible semantics. You cannot store a PDF in your system, in your laptop, or maybe in your server, or maybe in your corpus, by keeping all these things. That okay, there is a PDF, so let me maintain all the possible terms and their frequency. Let me maintain that how many times I have read this. I cannot maintain the number of terms particular term is related with other terms, something like that. You cannot maintain, it is not necessary, right? So that is the problem. We can have only few semantics with data at a time, right? So whenever you are processing data to achieve information, you can add only few semantics. And that is how each system is working. Like Google search system is working in one way, Google Scholar system is working in other way, and other systems. So each and every information processing system or maybe any search system is having a strategy to collect these information. So like in the social media platforms like maybe Facebook or maybe Twitter, they are collecting these user posts and their 3 4 features, like at what time it is posted, at what number of tweets it is having, retweets it is having, how many likes it is having, how many shares. So it is having these 3 4 information, right? And these 3 4 detailings will be maintained with the data, with the post, and maybe later on it will be utilized for some purpose, right? So it is up to your strategy, it is up to your platform, it is up to your system, that how many semantics we will be maintaining in the data, right? And these, so during this information search, during this search system, you will be utilizing these semantics to particularly. So fetching or fetching these 20 records from the 100 is not an issue, because you can apply some kind of matching algorithm. But secondary issue is that you need to provide the list of objects to the user in some way of some order of occurrences, right? So because fetching the data, fetching the exact match data is the basic thing which we have in the case of data processing also. Because you can see, if you can recall, in the SQL processing, so whenever you're writing a SQL query, uh, like if you want to retrieve all the employees which are working on department number one, all the employees which are getting salary 10,000. So you can have a simple query, select star from employee where salary is equals to 20,000, where department number is 20. So there we have performed exact matching, right? So exact matching is already implemented in the first quadrant itself, where we have data, where we have database, where we have SQL programming. But when we reaches up to the information quadrant, second quadrant, we have these additional semantics, right? So exact match you need to perform, but addition to that, we have semantics. And if you utilize these semantics, your search will be more user centric, more related to more inclined to the user. You can present the retrieve objects, fetched fetched objects to the user with some kind of relevance, some kind of basically you can say the concentration towards the user, something like that, right? So these are aspects. So basically the focus of any information retrieval system or maybe any such system is on the semantics part, how they are utilizing. So you can, if you collect all the possible search system in the internet, all the information processing system in the internet, the difference is on the second part, how they are utilizing the semantics, right? And that is the focus of each and every component within the search system, within the information retrieval system. There might be have we 4 or 6 different quadrants, six or 5 or 6 different computing blocks within the search system, and each and every component will be utilizing these semantics. So these details we will be discussing in the upcoming classes, right? So emphasizing semantics is the very important part, particularly with information, which will be utilized for n number of ways, right? So you can see in the social media platforms, they are generating these hashtags, so trending topics, trending words. So to generate these simple trending topics or trending words, they are utilizing one of the basic feature, like number of times that particular term has occurred in different posts, simply. So they are maintaining the number of times particular hashtag or maybe particular keyword has posted or maybe reposted or maybe anything like that. right? So similarly, in some information system, they are utilizing number of counts, they are utilizing number of repos, something like that, right? So it depends on the strategy of a particular search system or information system, which is utilizing these semantics, right? So going further, so because it is important to have a basic idea about the knowledge quadrant also. So after this, after getting these information objects and their relationship semantics, in some cases it is important to have uh, additional level of processing. So if you have this this information objects in a corpus, sometimes it is required to achieve a next level of abstraction, next level of detailing, right? And which is referred as a knowledge, right? So knowledge is doing, I mean, so to achieve this knowledge, what will we be doing? So you have information objects as an input and knowledge object as a output. Now to achieve this transformation information to knowledge, we will be adding something onto the information object, and that is done by, in conventional or in the modern context, you say, if you have a particular, if you have written an algorithm to basically attain some kind of learning, to some kind of training, right, to some kind of instruction generation. So these trained models, these learnings which we have gained into the algorithms, these instructions which we have derived and fetching into some robots, are the form of knowledge. So from information object to these instructions, these trained models, so this is transformation we are achieving. And naturally, to achieve this, we need to write a simple algorithm and then apply some kind of training onto it. Then after achieving this training, you will be applying some testing on it. So this third quadrant is basically available in most of the system nowadays, and this whole computational intelligence is running or maybe focusing on this third quadrant, right? So like we used to say that, okay, to train your model data, to train your algorithm, you need some kind of data set, right? So you can tell me, okay, right now, that you may be noting this question, that what is the difference between database and data set, right? So you cannot say that database and data set are same. That is very obvious question. That is very obvious observation you should have, that database and data sets are not similar. They're not the similar or analogous or in any way closer to each other, right? Because to generate knowledge, to generate the third quadrant detail, which is referred as knowledge, you need to supply data set or maybe information object to a particular algorithm so that you can generate knowledge. So naturally, data set could be analogous to information object, right? But there are a slight difference. There is a very slight, there is a very thin difference between information object or information collection corpus with data set. But to train a model, to derive the knowledge or to gain some learning into the algorithm, to gain some instructions, you need to supply either information object set or maybe data set, right? The after this, so this third quadrant is it is having again a very important aspect in computational world. But our focus course the focus of this course particularly is not to go into the details of this third quadrant. For that you might have different course also, because most of the times, or most of the students projects or thesis or dissertation, we are dealing with some aspect of this third quadrant, right? So at this third quadrant where we are having knowledge, there might be a separate representation we need, and it is referred as a knowledge representation. So sometimes people used to say, sir, is ontology is helping to achieve this representation? Yeah. So whenever we have knowledge, whenever we have knowledge object or knowledge details, we could have some kind of representation. We need a representation, right? So this is third quadrant. So after gaining all these things, because we are applying information object to algorithm and deriving some knowledge or gaining some knowledge. After achieving all these things, I don't know, and I can accept this fact that I am not sure about the possible representation at the fourth quadrant. How wisdom can be represented and how we can gain a wisdom. So out of these four quadrants, we have pointed out two aspects: how to achieve that particular, so how to achieve particular data, how to achieve information. That is first part. Second part is how it is represented. So like in data, we have said that, okay, this is the representation we have. In the information, this is the representation we have. For knowledge, this is the representation we could have, but I'm not sure about the wisdom quadrant, that how wisdom will be generated and how wisdom will be represented or stored, right? So you might have your impressions, but I have not read about any system which is generating the wisdom. Yes, humans can do that. Humans can achieve the wisdom after after applying these three quadrants. We can go up to the wisdom. So you cannot have data and directly attain a wisdom. You need to go through clockwise: data, then information, then knowledge, then wisdom. So whenever you are trying to attain wisdom, you need to perform all these three levels of processing. So like in humans, like in our life also, there might be some individuals which are called as a visionary, or maybe they're having some kind of wisdom on a certain phase of life, or certain part of life, or certain way of life, you can say. So it is very difficult to point out towards a particular application, particular software, and say that this system is generating some wisdom. I'm not sure about that, because robots, which we are assuming that are having nowadays some kind of self-control or self-assessment based intelligence, but they are still kept in the third quadrant only, right? So whenever we are training something, whenever we are applying some learning onto a model to behave in a certain way, it is still in the third quadrant. We are still on the third quadrant. We have not achieved this fourth quadrant, right? So it is not the focus of our courses, and you can see, or you can accept this fact that in the academics, or maybe in the institutional point of view, we don't have any specific course also which taught about this wisdom part. Because it is altogether a different new world, right? It is a new territory. So we don't have, at least in the computer science background, we don't have any particular course or in particular training or any particular certification which tells something about this fourth quadrant, right? So it is something which it is unknown for us, right? So we are not emphasizing something onto it. So I hope we have correctly opened up all these possible three quadrants, right? So there are a few points which are made in the notes below. The data information is something, it is data with some semantics, right? It is often referred as a process data. So there are a few characteristics which you can observe also, right? These additional semantics will help you to often retrieve relevant information. That is something which you have already made. Then to the user request, naturally. So whenever there is a user request to retrieve or to fetch the data or fetch the information, these semantics will be helping you to retrieve, right? And basically in the recent years, actually we are getting a lot of systems, lot of applications which are actually observing these semantics to achieve some kind of personalized or user centric. So here it is written that, okay, systems are observing or exploiting the user related behaviors: browsing, annotation, tagging. So there might be another maybe additional things are also. I have just pointed out very few or limited uh, on the data object, or maybe on the information. It could be on the both places, right? So right, so after that, so these human interactions are captured, right? So each and every this interaction with information is captured. Like in the search systems, they are the very first thing which a search system has added, that like in Google search also, in the year of like in our engineering days, we have observed that in 2006 or 2007, there is no, in Google search system only, in Google interface only, they have not added any query suggestion thing, right? If you type something, nowadays they used to populate these 5 or 6 suggestions, but in the 2006 2005, there is no feature like that, right? So in the 2006 2005 does not have this correction feature also. So they have added gradually a lot of features. Like they have introduced in the Google search, first they have introduced this uh, query correction feature, then they have these query suggestion, then they have query completion. So you might have heard these terms in the internet. If you search query collection, query completion, query correction, query completion, query suggestion, query auto completion. So these all things are achieved and implemented in the Google search systems. And naturally, to achieve this feature, you need to maintain some kind of additional things, like like to suggest the possible query suggestions. So if you type something, if you type a keyword on the Google search, it might suggest these 5 6 suggestions. So these suggestions are generated based on the, it might be based on the data. If you have stored the data, you can collect the possible next terms. That's what I'm saying now. You can basically compile the possible next keyword to each keyword in the document. So that you can do. Second, you can collect the possible history, possible query history from the all possible users of Indian users, or maybe any regional specific users, and based on that his query history or query history logs, you can suggest these query suggestion to you, right? So you need to maintain, your system need to maintain these semantics, right? So each and every interaction, that's what it is written, the human interactions are captured. These human interactions, it can be a query, it can be any behavior, click, or anything. And basically, based on this only, you can say you can achieve these personalized or user-centric information retrieval, right? So perform this user-centric, because now we are serving to a user, right? So these semantics are used to serve particular user operation, particular user retrieval, right? So these are the terms which are occurring nowadays. HCI, you might have heard about this term. It is called human-computer interaction. And if you say in modern days, so basically maybe in the last 10 years or maybe 8 years, it is becoming like information retrieval plus HCI. So it is nowadays, it is becoming like IIR, HII, HIB. So these are the abbreviations. Like this IIR stands for interactive information retrieval. So IIR is, so this conversational IR, which we have said yesterday, that uh, these all conversational IRs like Alexa, Siri, and all these bots, they are working on the very first model, which is called interactive information retrieval. You do not need to type anything. You need to simply apply your audio input, something like that. So it is something going beyond it. So you need to have some kind of interface to provide for the interaction, and after interaction, you can perform the traditional IR. So there is something additional added. So on the bottom, we have traditional IR setup, but you need to provide a layer where user is interacting, right? Secondly, we have other extension which is possible, that HII, it is human information interaction. So it is again an extension. There are various applications designed for that. Then we have HIV, which is human interaction, human information behavior, something like that. So when we combine with IR with HCI, HCI means it is so HCI basically gives you some kind of capability to operate on the systems, right? So when we combine with IR and HCI, so this is something is a recent or maybe the modern era of working, where people are working like, okay, so what could be the added on the top of the IR? So HCI is giving you the capacity to work upon the additional layer of the IR, right? So correctly, we have pointed out now, if you take, okay, this last part is given. So last part is, it is summarization of that. Okay, so whenever we are having this data, information, knowledge, and wisdom, so the first three level of details like data, information, and knowledge, they always based on the past experience. Past means past means here is basically the requirements which we have captured from the real world, right? So in the first three levels, data, information, and knowledge, we are dealing with the given requirements. We are dealing with the captured information, captured details about the scenario, and we are somehow processing it and achieving in a higher representation. But in the case of wisdom, it is talking about the future possible future data, right? So here you can see the difference. In the first three levels of processing, we are utilizing the previous data which is available, data which is pushed to the systems. But in the case of wisdom, if you are having any software system which is referred as a wisdom based data system, it should possibly generate the futuristic data. And that's why I'm saying it is a wild world, it is an open world. We cannot say anything on about this, that any system is generating wisdom, right? So it basically adds, it is kind of prediction. Can you predict the possible human being which will be appearing in the real world? Yes, some people are having this capacity to predict that, okay, in the upcoming 10 years there will be superhuman will be taking the birth in the universe. It is kind of that situation. So you cannot have a software system which could produce the futuristic data object, right? Something like that. Okay, so this picture basically summarizes the different possible aspects of the discussion we have taken in the today's class. So I'm stopping here, and if you have anything to ask, you can discuss with me right now related to today's class. If you have anything to ask, yes, please. Because so from today, I mean, from the next lecture onwards, we will be taking out the different aspect or different concepts from the syllabus of this course, right? So because we have correctly basically touched upon the different possible aspects. So from now, the focus of discussion will be entirely upon the information retrieval. So each and every detail which we'll be discussing the upcoming lectures, it will be purely on the information retrieval and web search, right? So we will be having different comparison study. We will be having some this kind of block diagram explanation. So all these things are planned here, right? So if you have anything to ask, you can ask, or maybe we can go for the closure of the class, right?
Sir,
Yes.
is there any book that you want to suggest us?
Book
Okay.
so in my way of teaching, I do not go for the specific book. I used to go for the collection of books and collection of papers. So book I will not be referring to you, yeah. So because 3-4 books are already given along with the syllabus. So if
Yes,
you
sir,
go
it is
for the
given.
syllabus, these 3-4 books are given because in the most of the uh, portion of the syllabus of this course, we don't have any specific definitions, right? So if you have specific definitions, you can go for a particular book. If most of the things are open, because these things are basically concepts actually, conceptual representation, concepts, logical explanation. So uh, by chapter wise chapter we can go for books, or maybe for some concepts we will be referring some research papers also, not entire research paper, maybe only introduction portion. So that's why I'm not suggesting anything. Yes, the possible contents which will be required to understand particular topic I will be posting in the class. Along with
Okay.
these class notes, I will be attaching in some particular lecture, I will be sharing you the very first page of a research paper, and I
Okay.
will try to annotate it. I will try to annotate it also, so that you can read it carefully or read it easily. Book I will not be suggesting. That is very sure. And this is
Okay.
not the new practice. We are doing this for the last 3 years actually, for this course itself. So it's
Okay.
okay, because this is how we will be doing, because we are not students, we are scholars actually. So we should be exploring all the possible sources, possible relevant sources to understand one concept, right?
Okay.
So I
Okay. Thank
think
you,
things
sir.
are clear. So we don't have any specific question to today's discussion. So let me close this class.